Hi, this is Rick. Let's talk about one of my favorite subjects, arrays. Now, you've probably already seen the two videos that accompany this one. They're real short little videos, and they explain the basics of arrays, and they kind of give you an idea of the analogies that are there. So I would really advise that you watch both of those videos before you get to this one, because it'll make a whole lot more sense. And the fact that it's repetition is just that much more learning. By the way, even though we're going to give you these presentations, they don't take the place of your book. Your book has a lot more detail and a lot more of the illustrations in there that are really, really good. So please take time to look at the upper right-hand corner of the slides, see the page numbers, and follow along. So the subjects for this particular chapter are next time we'll cover. So let's get started. You've probably seen this. This looks like an Excel spreadsheet, and it really is. And the nice thing about this is it's a very familiar type of layout. We've got the different rows labeled on the left, and then we've got those blank spaces to put things in. And that's really what an array looks like. I mean, it's just a parking lot for variables. So let's review what a variable is. Remember, a variable is actually a physical location in memory that has an identifying name and an identifying data type. So all the data types in this particular array are going to be the same. They're all going to be strings or ints or reals or whatever you want to call them, but they're all going to be the same. And at that point, you notice our numbering system starts from 0 to 9. Now, I don't want to defame anybody, but you know that kindergarten teacher that you had that you thought was so wonderful? Well, she did not tell you the truth. The truth is our numbering system starts with 0. So the first 10 digits are 0 through 9, and that's the way the computer thinks, so that's the way we have to think. So even though we think it starts with 1, it actually starts with 0. So let's take a look at an array. This is actually 4 different arrays, and as we go through it, you'll see that this actually a piece of computer memory that's divided up into pieces like an Excel spreadsheet. So here's our apartment array, or APT array. Here's our annual array. Now you say, what is this? Well, this is actually an example of 4 side-by-side arrays, and the table gives us the rent for apartments at the beach. So because that has a season to it, if you're going to rent apartment A for the year, it's going to be $9.89 a month. If you're going to rent it on a monthly basis, it's going to be $12.36, because that means we've got more expenses involved. And by the way, if you're going to do it in season monthly, it's going to be even more expensive because of the demand. So that's how these arrays are actually linked. They're actually 4 side-by-side arrays. APT, annual, monthly, in-season monthly. Elements. So we have elements of the array, and you'll notice apartment has element 0 is A. Annual array has element 1 is $1,018.67, and monthly element that we're pointing at is actually monthly 2, not 3, monthly 2 at $1,311.54. Let's take a look at the name. If we said apartment 4, what that really means is the name of the array is apartment, APT. We're shortening it up. And that 4 is called the subscript, and that's always an integer. And it's a number so that we can use it and count with it. So at that point, if we were to locate apartment array, element 4, it would be E. So you can start with at the top. A is in 0 position, B is in 1, C is in 2, D is in 3, E is in 4. Okay? In fact, let's practice that. See if you can locate in-season monthly 3. In-season monthly 3. It's right there. Okay? You begin to understand how this works. All right, let's try another one. How about annual 2? Can you locate annual 2? It's right there. All right, what about monthly array, position 6? or subscript 6? 0, 1, 2, 3, 4, 5. Okay, right there. 0, 1, 2, 3, 4, 5. Okay, got it. All right, so that's the basics of the array. And by the way, an array allows you to store a group of items of the same data type together in memory. So they're all grouped together, and the nice thing about that is we can just walk on down with a little formula. And why do we do that? Because instead of creating multiple similar variables such as employee 1, employee 2, employee 3, and so on, we just create an array. To do that, we just declare, in this particular case, we would declare a string array named employees. And see those brackets? They surround the number 50. That means that the string array called employees is going to be 50 elements big. All right? And here's another one. We can say, okay, declare a real, which is a number, array called sales amounts, and it's going to be 7 elements big. So the number in the brackets is the size of the array. All right, here's another way of looking at it. This is the storage location system, and so we say that each of these open elements is going to contain a number. So when we assign values, then we do that individually. We can do that individually. So we could say that we could set classroom 0. Now, what does that mean? Well, it means we're going to make the classroom array element 0 or position 0 equal to the number 20. And we're going to put 30 into the classroom array position 1 or element 1. The classroom array element 2, we're going to put the number 40, and we're going to put 50 in the classroom array position 3. And in 4, we would put 60. So classroom array position 4 or element 4 is equal to 60. And we can do that. We can do that in the program itself. But it's much more efficient to step through it with a loop. So this is what we might want to do. Turn to page 292 and trace the pseudocode in program number 1. And then pause again, go to page 294 and trace the pseudocode in program 3 and see if you can see the difference between those two. It's really important. So here we're back to array basics, and we're on page 293, and you'll notice that we've got an array called hours, and we've got hours is actually 3 elements big, and we've got 40, 20, and 15 stuffed in there. So the contents of the hours array is contained in the hours elements. So turn to page 338 and do short answer number 2 and 3. Now turn to page 337 and go do the checkpoint review questions 1 through 6. Welcome back. Let's create this array, and basically an array is like a parking lot for variables. So if a variable is just one position in memory, then an array is a parking lot worth, or a whole bunch, and they're all together. So normally what we do is we create the array, and then we fill the array with a loop, and the sentinel value equals the array size, usually, and I is used for the index or the subscript, and then we're going to process stuff. Once it's in the array, we can process it. So we've created the array, we use a loop to input stuff into the array, and then we process the array, and then we display the array contents with another loop. So in summary, it's going to look like this. We make the array, we loop to populate it, we process it, and then we loop to display it. Turn to page 294 and look at program number 3. Look at the logic there, and you'll see that we're going to follow this very pattern. We're going to make the array in line 6. We're going to loop to populate it in lines 12 through 16. We're going to process the stuff. Well, there's nothing processed in this particular example. That's the reason I like it. It's so simple. And then we're going to use a loop to display all the contents of each one of those elements, and that's going to be in lines 20 through 22. All right, arrays can be initialized with numbers or specific values. So for example, if we had a string array called days and we made that 7 elements big, we could then say the array population, or populating the array elements, can be done right there in the declaration statement. So we're going to put Sunday. Now it's in quotes because it's a string, remember? So we're going to put Sunday in 0, Monday in 1, Tuesday in 2, Wednesday in 3, Thursday in 4, Friday in 5, and Saturday in 6. Remember that we're starting with 0, so it's going to be 0 through 6 is our numbering system. One of the things that you're going to got to watch out for is this thing called off by 1 error in looping. And that means basically if we say, oh, what's day 7, or day 7 equals Saturday, sorry, that the days array does contain 7 elements, but there's 0 through 6. There's no such thing as this days array element 7. So it's invalid, and it's a really common error. It happens all the time, and I'll show you a way around it in just a minute. But the idea is it's called an off by 1 error. So if you get a note on your homework that you've made an off by 1 error, it means that you didn't start with that 0 thing. So let's go back to our checkpoint and take a look at the algorithm workbench and see if you can do a flowchart. I'm going to show you the pseudocode in just a minute, but see if you can do algorithm workbench and do a flowchart of problem number 1. All right, this is the answer in pseudocode. So we said there's going to be a constant integer named size, and we're going to make size equal to 4. Now, why do we do that? This sounds like a lot of trouble to me. Well, the idea is that you can come in and change the size of array, the number of elements in an array, by just changing this one variable, and it changes it. Then we're going to declare a string named scientists, and we're going to make it the size of our size variable, which is 4. And then we're going to say that's going to equal to, and then we're going to populate it with Einstein, Newton, Copernicus, and Kepler. You can use constants in the array element values. So in this particular case, we had the days of the week beforehand. Now we've got the months, and we're going to create a string array called month, and we're going to make it 12 elements big. So we've got January, February, March, April, May, June. But you know, when you actually write this program and you put in month 4, you would expect to see April. Or you put in month 1, you would expect to see January. So what I'm going to do is say, okay, I'm going to make a string. Now look over here on the right. I'm going to look over here and say I'm going to make a string called month. And I'm going to make it 13 big. I'm going to make it 13 elements. And what am I going to do with this? Well, I'm actually going to have my string, and this one goes from 0 to 9. That's because I ran out of screen space. But the idea is that it starts at 0. Now, if I were going to look at this and troubleshoot it, then I would expect to see, when I put in month 1, January pop up. But unfortunately, because of the way I've done it with month size 12, then I've got January in position 0. So I've actually said, okay, I'm going to make a string array called month, and I'm going to make it 13 big, and I'm going to put my name in the number 0 position. And then 1 is January, and 2 is February, and 3 is March, just exactly as I would have expected it to occur when I typed it in. So if I said, okay, month 9 is September, and I expect that, and it is in the array as well. So that's the way around that 0 error. So this is how to avoid the off by 1 error, and it's on page 299. All right, let's go to the checkpoint. And in the checkpoint, we want to do algorithm workbench, and we don't want to do a flowchart of problem 2. I'm going to show you just a minute the pseudocode. Assume names is an integer array with 20 elements. Design a for loop that displays each element of the array. Okay, so I'm going to say for index 0 to 19, because it's going to be 20. That's actually 20 numbers, but they start with 0. And then I'm going to say display the names array position or element index. So it's going to count starting with 0 and go to 19. And then I'm going to end the for statement. And that's all there is to it.